Oh wow, where to begin? Also, this is a topic I could literally go on for a long time. So you're going to have to like flag me down and tell me to like shut up. So I mean, I've already done one video on this topic. So if please somebody like give me like a 5 minute warning or something because I've already done a 35-minute video on this topic on YouTube, which I think some of you have seen because I've never. I've spoken at events before, but this is the first time I've spoken to an event. I've been on the agenda for an event. I've actually had people like coming up to me and like pulling me aside and telling me, "I watched this video and I had a question about this." I did. So it's incredible the outpouring of interest in context graphs. And so, how many of you have seen like this was a topic that just absolutely erupted over the holidays, literally over the Christmas break, because of an article that was written by Foundation Capital, which was interesting in how they described the technology, which spurred myself and quite a few other people to write follow-up articles to try to kind of I don't want to say set the record straight, but try to give a broader interpretation of what this term is. So I'm going to give a really simple definition. And I don't know, I don't think this is the term that some people like, the definition some people like, but my definition of a context graph is going to be, it is simply a graph structure that is optimized for usage with AI. And you're thinking, well, that sounds kind of vague. Well, as I go through this, hopefully that's going to make a little bit more sense. But also, I don't like just giving talks and making people stare at slides. So if you have questions, if you have anything to say, just shout it out at me, raise your hand. I would much rather people make this, if you have questions, just don't let me go by it. Hold me to it if you don't agree with something, unless you happen to be the CEO of a graph database company, then I'm not going to answer your questions. Or are you the only one? Do we have any other CEOs of graph database companies here by chance that happen to actually be integrated with TrustGraph, actually? So, yeah, I know I could go. I get spun up on this topic really quickly. So, what is all the fuss about? Well, the fuss is about, for the most part, people were calling this RAG for a long time. And weirdly, I don't have an answer for why this is. There are a lot of people that really think or want to say that RAG is only for vector embedding, vector search based pipelines and workflows, which is really, really strange because people like ourselves and many, many, many others have been doing this with graph systems for 2 to 3 years now. I mean, even Microsoft released their graph RAG project 2 years ago. So I find it really odd. It oftentimes seems to come from some of the vector database people. But so, I mean, the crux of it is really that, somebody's trying to use AI, and we've all gotten to that point now where we realize that if you just ask an LLM directly to do a bunch of things, there are some things that it's going to do well, and there's a lot of things it's not going to do so well, especially if you really need it to be precise, you need it to be accurate. Like, for instance, I posted on Twitter this weekend that I was talking to a friend of mine about this band that we care about, and what are the top 10 songs this band has played live and throughout their career? And you would think, and they even have a website where all this data is, and you would think, oh, AI can solve that problem, right? I gave it to ChatGPT, I gave it to Claude, I gave it to Gemini, I gave it to Perplexity. Not only did they all get it wrong, you could actually see this on my Twitter, Perplexity actually gave me a top 10 list table, which was out of order. Like, the one that they put at number 10 should have been like number 4. Like, it can't even put a list together because AI doesn't store values associated with like data. Like, it can't go, this time song X was played as Y. It just can't do that. Which is why we need all these other structures to find these sorts of relationships, to find these sorts of values. And there's so much stuff that we can do with all this. So much stuff, but I'm getting ahead of myself. A lot of the discourse around context graphs, matter of fact, if you read that initial article, a lot of it was around this part. They talked about decision traces. They talked about systems of records. Matter of fact, they've now tried to backtrack on the term graph at all. I was told by the original author on Twitter of the original article that it doesn't have to be a graph after all. I'm like, wasn't that the whole point to begin with? But okay. So many people have focused on this part and neither of these parts. This part, a lot of us have been working on for years. This part's kind of new. Let's talk about what these are. Well, first of all, and also, I guess this is a good question actually to ask. Should I go into really technical details, or would you rather me focus more on the why does this matter for me as a user or an enterprise? What do we think? Why? We don't want technical gory details.
We'll read that later.
Well, I have like 5 articles. I have another article. I didn't get to finish it today, so it may be tomorrow. But the crux of all of this at the most fundamental layer. So when we talk about graphs, it's really just this simple. We know that databases, a schema, a Postgres, tables. You have keys and values. Well, a graph is just when you have subject, predicate, object. And it used to be, some people argued there was verb way a long time ago, but a long time ago they decided predicate was better. So if Bob is the son of Alice, you would say, Alice is mother of Bob. So that's how you would join these together. Since people said they wanted to not do the gory details, we'll just assume that everybody kind of gets that. CEOs of graph databases that are property graphs, please refrain from throwing things right now. There are 2 key ways to structure these. And believe me, and you don't have to ask me, I'm sure Guy will say the same thing. The graph community gets really, 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 really evangelical when they think one of these is the right way over the other. Really, really. We happen to kind of ride in the middle because we do both of these, which is really unusual. So what I'm getting at here is there's 2 schools of thought. And I actually met somebody earlier who there you are, that actually is well versed in the semantic web and the whole promise of what the semantic web was. This goes back to the late 90s. It was this idea that we would create graph structures for interoperability so that we could exchange information from different websites in a way that we would easily be able to understand. The one that is the most well known is schema.org. How many people here, if you've ever done anything, especially a few years ago with SEO, you know about schema.org because that's how that was how they wanted you to structure information in your website for how they use that for Google search. So that's more of the RDF style semantic web approach. Property graphs is where you take these relationships, subject, predicate, object, and you start adding different kind of data to that. So that you can say that Alice knows Bob's, and you start asking well, when did Alice know Bob? How does Alice know Bob? That sort of stuff. It gets messy really fast. So the co-founder of TrustGraph, Mark, is actually the true expert on this stuff. I had to learn it from him. And I remember when I was first learning RDF years ago, I kept going, I don't understand this. What is this? So as a joke, he built an example. He built an example for me using his cat Fred as an example. So we took just 3 simple statements about Fred the cat. And by the way, Hope is another cat, which is interesting because that causes some disambiguation, which is also something that you would learn about in the graph. And it takes all of this, and this actually isn't all of it. This is just part of it. We have this guide on it's on our GitHub, and it's linked in my context graph manifesto of all the stuff that you have to do to take 3 simple statements and structure it in a way that's in this nice, richly structured graph. And you're probably thinking, why on earth would I do that? Well, it's because what happens when you have thousands of these relationships, tens of thousands and millions, and you're trying to find how Fred the cat and Hope are related and how you're trying to find stuff you never knew before. That's why. Oh yeah, I put that in here. Yeah, it gets even worse. RDF is a true eyesore. It's hard to learn. It really is. You'd be amazed at how many ontologies are out there. let me put an asterisk right here. If you read any of the original articles about context graphs, the word ontology did get thrown around a lot, and it gets thrown around a lot because of a certain company that's named after a Lord of the Rings item, and I'll leave it at that. Um, and there's this idea that ontologies are something that you build for a specific use case. That's not really true. They're not thousands, there are hundreds of thousands of ontologies that are in use today in enterprises that are industry standard amongst all of them. Because even the BBC, I think it may be just bbc.co.uk/ontology, I think. They have an entire library of ontologies for all sorts of stuff that you can just download. This is one that's actually, I can't remember, it's about political something, yeah. So yeah, we can see in here, we got stuff about elections and people. So this is actually really, this is common usage. That's another theme I want to get at. This is not new. It is not new. So a little bit more about ontologies. These are some 3 common ones. Actually, I take that back. 2 common ones and one I just happen to like. Schema.org, very, very well known. This is something that Google has used for a very long time. OWL. OWL is a little bit more like a taxonomy, sort of. But ontology is an extension of a taxonomy. Like I said, there's a lot I could talk about here. It gets, well, some people might say like I'm splitting semantic hairs with all this stuff, but that's kind of the point. We're talking about the collision of technology and human communication now. And we're all in this room, I think, because we're seeing that building these systems to be reliable and accurate, that we can actually get value out of, has run into a lot of challenges. And it's because of the imperfections and ambiguity in human language. So these are things that we have to consider. How do we structure them? What's the difference between a vocabulary and a taxonomy? Yeah, it's a slight difference, but that difference actually matters. SCOs is an old one that kind of didn't get a lot of use. It's more conceptual in its structure. We actually have one trust graph user that told me that they actually do use SCOs, and I was very excited about that. Here's another reason why this matters. LLMs like it. Yeah, they like it. So let's imagine that we've done we have some RAG pipeline and we have some context and we're trying to give it to the LLM to improve the responses. We could just structure it as like sentences, paragraphs. Okay. A lot of times, excuse me. A lot of times people tell you, well, some of the frontier model developers will actually tell you like bulleted list, symbols, that helps. But if you really dig deep, they'll talk about structures. They'll talk about XML especially. So what we found is that if you provide an LLM information that's in a data structure like this, it seems to perform better. So we started thinking about that. Why might that be? Well, this is stuff that we as humans can easily understand. This is stuff that's for us. We designed this stuff to be the bridge between humans and machines. So humans, we can't read this so easily, but a machine can. And we've trained LLMs on mountains of machine-readable language and code. So it can read this stuff the same way that if you're bilingual, you can read both languages. To an LLM, reading Python and Java and reading English is the same thing. It knows it. So what's interesting about this is there's inherently information stored in the structure itself. Because if I tell it this is RDF in triples, which is this is sort of in triples, it automatically knows like, well, this is a subject, this is a predicate, this is an object, and it knows, well, okay, this is a graph structure, these are relationships, and it's going to think, I don't like using that word, but think about this information in a different way. And when we start talking about graphs, there's so much we can do. I don't, for the most part, the people kind of doing graph RAG, and ourselves included, have been focused a lot on the foundational work. We haven't really even gotten to the multitude of really sophisticated graph retrieval methodologies that are out there and mature, from being able to choose your path traversal. Do you want to take the shortest path between two nodes? Do you want to take the longest path between the two nodes? Do you want to start looking at clustering? Do you want to start looking at the density of nodes and information around those nodes? Or do you even want to do anomaly detection? Anomaly detection, boy, that's a really, really big one, especially if you're in the finance world. Fraud detection is built on that. Cybersecurity, most cybersecurity products under the hood are graphs and a lot of anomaly detection. So here's a topic that's it's a little, we're getting a little complicated now, or not. This is kind of where RDF style graphs, the semantic web, diverged from property graphs, people like Guy and FalcoDB's approach, because RDF didn't do a very good job of doing reification. So what is reification? Believe it or not, this is the best definition I ever saw. I don't know. If you know a better definition, Guy, please tell me. I like this one. Statements about statements. I know that seems ambiguous, but believe me, the other definitions are worse. So basically what I'm saying is that we know that Fred has 4 legs. He's a cat. He has 4 legs. So what if I want to know information about that statement? Like that Mark told me that Fred had 4 legs, and that when he told me that. That's reification. I want to know what is additional information that's related to that initial fact. Now, in RDF, that's messy to do that. It's kind of weird. You have to basically create this secondary statement, which this is kind of neat in and of itself, but there's a problem. This isn't really connected to this in any way. You can query it, but it's messy. This is where property graphs really excelled, because you can append properties to the entire edge. So this is where, if Neo4j is a well-known property graph, if you've ever played with it, of course, FalcoDB, many others, this is kind of where they've really shined. Now, the interesting thing is, just a couple weeks before the context graph conversation got started, out of the blue, the RDF people awoken from their slumber and hadn't published anything in close to a decade, and published the draft RDF 1.2. Yes, RDF is all the way from the late 90s, and they're just on version 1.2. They really move at a blistering pace, those people. And they have introduced reification in RDF 1.2, so that you can now take an entire relationship and add statements about statements. So now both approaches, there are ways to kind of do the same thing. So what happens though when we have these AI systems and we have agents and we've asked them to do all this stuff, generate emails, generate reports, do work, and the work that a human would have done? This is this is your intellectual property. It is what your company has produced, except now it's synthetic. It wasn't generated by your employees. It's been generated by a system, an intelligent system. This is your new data. What do you do with it? You have to close the loop. And that's where I don't think anybody's pushed into that boundary yet. Oh yeah, I was going to talk about this. Okay, sidebar. I'm glad I remembered this. Remember how I told you this isn't new? So I hope everybody goes away with this and just remembers. The term context graph is not new either. So you can find it in the literature going back 20 years, but kind of used just in the knowledge graph way, nothing very specific. However, Vicky Frowen, if I'm saying that correctly, if any, is he Belgian? I think he's Belgian. So if Flemish, I don't know. Let me know if I got that wrong. He gave a talk in 2019 while at Calibra about context graphs in this same exact context, because he's a cognitive scientist who is really into how you build intelligent systems. So what is old will become new again. There you go. Context graphs, not the hot topic of 2025. It is a forgotten topic of 2019. And I'm going to be doing a podcast with Vicky in about 2 weeks' time. Stay tuned for that, where we're going to talk about what he was thinking when he came up with this term. And He has a really, really great perspective on uh, cognitive science, human psychology, how it plays into intelligent systems, and what he really thinks about Jeffrey Hinton, which he has some strong opinions. So looking back at this now, so what do we talk about with a context graph? I know I've talked about a lot of stuff. I've talked about a lot. I hope I haven't confused you more than I've helped. It's entirely possible. I can't even remember what I've been talking about because, like I said, I could talk about a lot of things. But this part, if I don't quit hitting the button, this part is one that has kind of been overlooked in this discussion, the initial grounding. Remember how I talked about the whole RAG piece? That's just been overlooked in the context graph discussion, is that you still take your data and you structure it in graphs. You could structure it in an RDS style graph with not with a flat structure. You could structure it with ontologies. You could structure it in a property graph. But still, that's a very important part of a context graph, is because it is how you store the context you want to provide your AI system. That part has just kind of been overlooked. This part, the system of records, the decision traces, that's reification is what that really is, because you already have this context in your graph and you want to know how it was used by an agent. That's reification. So when you pull context from the graph, you can add that data to those statements, and now you have this rich graph that not only has the data that you wanted to use to ground the agent responses, but how it was used. And then this layer on top is when all of this gets fed back in. And we start looking at temporal relationships, how the data changes over time. Does it change over time? We start looking at things like context drift. How do we compare to our initial grounding state? Are we different? Has it changed? How has it changed? Should it change? Maybe it shouldn't change. Maybe it's a good thing it changed. Maybe we were wrong. These are all, keep hitting that button. These are all things that we can start calculating and understanding once we start closing the loop on all this. And I am a co-creator of TrustGraph. It is completely free and open source. I actually changed it to Context Graph Engine today. I kind of felt that was a little bit better. Let me know if you like Factory instead. I can easily change it back. Yes, you have a...
Yeah, what's the best easy human way to create context graphs? And is there something like a pandoc that translates from one type of structure to another?
Well, as I was saying to somebody earlier, building graphs is pretty easy. It's the getting the data out of the graph that's the challenging part. And there are a lot of different ways we can do that. Like I said, we offer two different ways in TrustGraph where we can take your data, your unstructured data or your structured data, and use them in our process. We'll build a graph for you, totally automated, either way you want to do it. So totally automated, you don't have to code anything. I think FalconDB probably, I think you guys have something similar to that. Everybody has like a solution for that. Interoperability between graphs is kind of a no. Everybody has kind of their own way of doing it. For instance, our processors are native to use Cassandra by default. So our support for FalconDB, Neo4j, MemGraph, etc., requires us to do some translation to be able to store things in those graphs. Like I said, the graph community has very strong opinions about what the right way to do things are. So interoperability was never really higher in their list of things to do because they're really convinced their way is the right way. So that's just kind of an unfortunate thing. But again, my answer to that is that's why we made it totally open source. It will always be open source. And we tried to make it as interoperable as we possibly can in that regard. I hope that kind of answered the question. Some of the content I've written, if you want to read more about this, I was the Context Graph Manifesto, which isn't as angry as it sounds, I promise. Reification, which I know that people are really excited about that term, and that's not something they're going, what is that? actually, one of the articles, this is the article I'm the most proud of, actually. And I'm a little, unfortunately, I didn't get to talk about that too much right now, about determinism. Determinism is going to be probably one of the hottest terms of 2026 and 2027. Um, if you're a buyer in an enterprise and looking at AI transformation, that is a word that is on the top of their mind right now. I have had so many meetings in the last couple of weeks specifically because of this article, even though it got the least viewership of all of them, because that's what people in enterprises are really, really worried about, is how do I know that this system is going to produce only the outcomes I want and not bad outcomes. And they want to see a path to how they can guarantee that. I also have a video on YouTube where I talked about even the stuff even more. And as I said, our YouTube channel, I'll have this conversation with Vicky going up in a couple of weeks. And we're also going to have an online event where we're going to do context graphs in action, where we're actually going to do live demos of this stuff and how it actually works and what it all means. I think that's it.